So the most basic type of a slope field problem or differential equations problem that you're going to get when you get the AP exam is to determine the slope field. So they'll actually give you a graph provided, and you're going to have to sketch the slope field. Does anybody know what dy over dx means in calculus? It means the derivative, okay? And so it says that the derivative of the function is really equal to x plus 1. So as we sketch the slope field, all we do is we identify a point on the graph, and we determine the slope at that point. So somebody, if this coordinate right here, each tick mark is 1, somebody give me a coordinate that's on the graph. I don't care which coordinate, pick it out. Okay, so if we pick out 1, 2, it says that the slope value at 1, 2 will be the x value, which is 1 plus 1. So the slope value at the point 1, 2 is 2. So I go over to 1, 2, 1, 2 right here, and I draw a slope of 2. I just make a segment because it's going to change at every point. I'm going to try a really easy one here. How about 0, 0? What is the x value at 0, 0? So what is the slope? 1. So I draw a little segment with a slope of 1. I know right now that this does not relate to a whole lot of things you've done before, but we just have to think about in terms of relating to previous information that we are talking about slope. I'll connect it a little bit later, but right now let's just try to go through the exercise. Would you agree that everything on the y-axis has an x value of 0? So therefore the slope along the y-axis will always be 1. Does everybody see that? So that's a nice way to identify kind of, I guess, patterns or trends or consistencies throughout. And would everybody agree that where Allison picked a point at 1, 2, if I look at that vertical alignment right here, all these x values do have an x value of 1. So they will all have a slope of 2. Now, when they grade the AP test, they're teachers like me, and they want to try to give you points. They really do. So I think that drawing a slope of 1, you really want to make sure you draw a good slope of 1. Slope of 2 should just be more than 1. After that, it's kind of hard to tell the difference, right? And they understand that. They're thinking, draw it positive and steep, okay? So what is the x value all along here? 2, so the slope is 3. And the very last one, the x value is 3, so the slope is 4. And we'll pick up there when you get back, but you won't see the complete slope field, and you'll try a few on your own, okay? First let's finish this off, okay? If I back up 1, what are all the x values here? And if we add 1, we'll get... Here all the x values are, so the slope will be here all the x values are -2, so the slope will -3, so the slope will be -2. Now, if that was a question on the AP exam, you would be given a full point for that work right there, okay? That is suitable. Now, you might say, are my lines exact enough? It's important that your slope of 0 looks like it's 0, 1 and -1 look like that. And then after that, you want to be, I mean, who knows if that's actually 2? It kind of looks like the 3 and 4 look basically the same, don't they? They don't care about that, you guys. They get that it's tough to do, but this is an excellent answer. Got that? You try to do the next one on your own. Okay? So you're going to take 2 times the y value. See if you can do that. 2 times the y value. Everybody done? You can look up when you're done. Let's see if you got it. So part of what I do when I looked at it is I said all the y values here are 0 along the x-axis. So all these slopes will be 0. And then I looked at one line up, and I said all these are y values of 1, so they'll all have slopes of 2. So I saw that something would remain consistent the entire way. And like I said, you just got to kind of look for those patterns and those trends. So for like number 3, x plus y, what will be the slope right here at 0, 0? Okay? Now, here's what I'm going to do. Is I like 0, okay? I think 0 is just a great number to work with. So if I want to get 0, I need the x and the y values to be opposite. Which, give me an example of a coordinate where the x and y values are opposite. Negative 1, 1. So negative 1, positive 1. Okay? So you can see that very quickly I can find a number of points that are opposite in value between the x coordinate and the y coordinate. If you add them together, you'll get 0. Okay? The x and the y-axis are going to be easy to do. For example, the x value is 0. So 0 plus 1 gives me 1. 0 plus 2 gives me 2. 0 and negative 1 give me negative 1. 0 and negative 2 give me negative 2. And you can continue to, do that for these as well. So already I'm formulating a lot of different pieces to the slope field here. And after a while, there's just not much you can do other than just pick a point. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 2 plus 2 is 4. 3 plus 1 is 4. 5. I mean, after a while, you just got to go through and pick every one and do it. But you get the idea, right? I mean, we could spend a lot of time here just making little tick marks, but just didn't want to miss math, huh? Gotcha. I like that. All right, very good. Okay, so let's look at problem number 4. Number 4 is where you get a lot more interesting in my thought. Okay, so where am I going to get values of 0? Wherever x is equal to 0. Where is x equal to 0 on the graph? So which axis? The y-axis. Does everybody agree on the y-axis? X is 0. So therefore, all of these will have slopes of 0. Now, for all these x values here, all these x values are equal to 1, so the slope is 2. And then 2 times 2 is 4. Okay. What are the x values here? Negative 1, so the slope will be so I made a slope field pretty quickly, huh? Now, let me sidebar for a second and show you something that's really interesting. So you can see kind of where we're headed with this topic. Dy over dx is equal to 2x. I'm going to cross multiply, and I'm going to get dy is equal to 2x dx. Now, I want to get rid of the dy and the dx, so I'm going to do something that you're familiar with. I'm going to stick an integral sign in front of it. What is the integral of 2x dx? Do you remember doing that? x squared plus a constant, right? Equals, and the integral of y, if you just have a 1 in front of it, what's the antiderivative of 1? Y. Okay, y equals x squared plus c. What shape does that make? A parabola. Look at graph number 4. Do you see the parabola? Do you see how if you were to draw the parabola in there, the slope fields seem to match up? So this is a slope field for a parabola. The deal is we have a plus a constant on the end. We don't know if it starts at -1. We don't know if it starts at +1. But we know that this retains a general slope field. See that? That's where we're headed, okay? That's where we're headed. No, 2 dy equals 2x dx is an expression of itself. What I'm saying is I would like to solve for y. And in order to get rid of dy and dx, I get rid of that by inserting an integral symbol. I take the integral of both sides. Try number 6. Last one. Try number 6 on your own. Okay? Glance up where you're at. Are you coming up with something approximately like this? Did you get zeros along the x-axis? Get vertical lines along the y-axis. Everywhere in the first quadrant should have negative. Can somebody give me a description why everything in the first quadrant should end up with a negative slope? X and y are both positive, and when you insert the negative, you'll get negative then. Same should be for which quadrant? Third. What should the slopes be in second and fourth? Positive, because you have one negative, and after that negative, it will go away and give you positive. Do you see that? Sometimes when you look for slope field, that's what you want to think about. Positive, negative, 0. Okay? And so that's what we have. Okay? All right, I'll flip it over. Let's try something else. Let's try a matching problem. Okay? Right now, I want you to match A, B, C, and D with 7, 8, 9, and 10. Okay? Try to come up with the slope field that matches with the differential equation. Okay? Which do you think is the easiest one to start with here? Yep, I would start with number 10. dy over dx is equal to x. I would start there, okay? Go ahead and give that a shot, okay? What'd you come up with for number 10? B is correct. How about 9? A is correct. 8? D. Good job. What is the antiderivative of sine? Negative cosine of x. Do you see that if you insert a negative cosine of x, that will create that kind of a shape? So a couple ways to think about these problems, right? Okay. So I actually, when I did this problem, you guys all said 10. I think 10 is a great answer for where to start. I started right away at 7. I started at sine. I said antiderivative is negative cosine. Negative cosine fits that graph. Okay. As you look at number 10, x, the antiderivative of x is going to be x squared. You can see that b obviously fits a parabola. Now, that's not necessarily the best way to always do it, but if you see those tendencies right away, it's good. This is a little bit more difficult. Okay, try 11, 12, 13, 14. Or did you already do it? Okay, take one more minute in case you haven't. Try 11, 12, 13, 14 match slopes. Okay. B, C, D, A. Okay. All right. Let's move along. Flip it over. Actually, let's please go to this page right here. Okay. Separable differential equations. So let's practice a little bit of the algebra again. You're not going to have an assignment on this tonight. Sam, do you recall ever setting up a problem like this on the AP exam, where you cross multiply and you find the antiderivative? I know it was a long time ago. Okay. So I'm going to rewrite this expression as e to the x over e to the y. Does everybody see why I can write e to the x minus y as e to the x over e to the y? Same base, so therefore you would subtract the exponents. This is going to make finding the differential equation much easier here. We're going to find a general solution, the general solution, not the particular solution. We'll practice that tomorrow. So I cross multiply, and I get e to the y dy is equal to e to the x dx. I want to get rid of the dy and the dx. What operator do we use to get rid of the dy and the dx? The integral symbol. Can somebody tell me what the antiderivative of e to the x is? E to the x. Thank you, Jack, for stating that. Natural log is always a good guess anytime you see e, but unfortunately you were 100% wrong. All right. Plus a constant is equal to, what's the antiderivative of e to the y? E to the y. Now, you might want to add a constant. If we could just get over this right now, this would be great. E to the y plus a constant, we'll say constant 1, is equal to e to the x plus a constant. We'll say constant 2. So that's really e to the y is equal to e to the x plus a constant 2 minus a constant 1, which is just a different constant, right? See what I'm saying? It's just a constant. So that's why we don't put the constant over here. We just leave it over there. Because we would end up subtracting over, getting a different constant anyway. So who cares, right? So now I need to solve for y. Jack, what do I do to both sides to get rid of the e? Natural log both sides. Darn right you do. So I'll natural log both sides, and I get y is equal to the natural log of e to the x plus whatever constant we have. Now, the particular solution would actually figure out what that constant was. We'll do one more and leave you guys on your way. I cross multiply. Secant squared of y dy is equal to dx. What is the antiderivative of secant squared? Oh, come on. We tested on this many times. Tangent, thank you. Tangent of y is equal to, and what's the antiderivative of 1? X plus a constant. How do I get rid of tangent? I want to solve for y. Get rid of tangent. Inverse tan or arctan. So y equals arctan of both sides. So x plus c, then the arctan. Very good. And we pause there. The general solution is listed. We'll pick up tomorrow. Yeah. This is the whole point is that you just end up with a constant. It doesn't matter whether it's C1, C2, or C3. Not right now anyway. This is a 1. What's the antiderivative of 1? Yeah, because you're going to do, because what I did is I did the integral of both sides. Antiderivatives, well, here we want to get rid of the dy, so we have to take the antiderivative. That's what's happening. No assignment tonight, folks.